So after submitting, good job. Check the bottom here because for any error messages, and it says here job 1 completed successfully. When a job is completed successfully, the output file has an extension of ODB, which is our output database. So I'm gonna open, and I'm gonna open the ODB, which is output database. The job that I created, I called it 1, so this is the output database file. Alright, so you can view a few things. This is the deformation, and you can see how the boundary conditions are satisfied. You can plot different things. So for example, and you can plot multi-plots. So the first thing I'd like you to notice is the stresses. So I'm going to click on results, field output. There are a few things that you can plot. You've got the various stress components, S11, S22, S33, S12. Of course, 1 being X, 2 being Y, 3 being Z. And you can also plot the stress invariance, maximum in plane, minimum in plane, out of plane principle, and all those. So I'm just going to choose to plot the stress in the X direction. Apply or OK, or contour plot. Now, a very important aspect of finite element analysis is that the stresses, while they appear continuous, they are not really continuous, unless your approximation or your element size are really small. So I just want you to click or see that if I click on results and options, and if I change the averaging to 0, apply, you can see that the stresses are not really continuous between elements, but the approximation is good enough. If I want to find the deflection, for example, there are different ways. I can use the query node, this node, and it gives me the displacement in X, displacement in Y. So the displacement in Y is negative 1.366 times 10 power negative 1. Now we can plot, for example, the displacement versus load. So in order to do this, I will have to create an XY plot or XY data. A field output database field output, continue. Let's nodes, find the nodes. The magnitude of, let's say, the deflection, U1. Pick the node and its selection, this node. Done. Sorry, U2 rather than U1. That's the vertical displacement. Plot. Dismiss. And then I'm going to go to report this data, XY plot in current viewport. I'm going to click this one, which is the displacement curve. The setup, I'm going to call it, let's say, one.report, and I'm not going to append to file. Apply, cancel. So it says here the XY report was written to file 1.rpt. And let's create another file with the stresses. So I'm going to create another XY. First I'm going to view the deformed shape. Again, create XY data. Continue. Let's, for example, plot. Maybe I can plot the logarithmic strain or the stresses or whatever. Let's. I'm going to choose the stresses at the centroid of an element. The stress. Let's say the S11, S22, and S33, S12. I'm not going to plot the S33 for plane stress is 0, so I don't need that. And let's say for this element, at the centroid of the element, plot. Oh, I need to take this out. So S11, S22, S12, plot, dismiss, and I can also choose those three and stresses.rpt. Okay, and this was written to file stresses.rpt. I can also do other things. I can animate. So for example, I can animate the deformation, scale factor, or time history. So this is as the load is applied, and you can save this as an AVI file for your presentations. I can also print. So I can, let's say the stresses, I can print to a file for use on your presentations or for any of your assignments, for example. So you can print to a TIFF image and save it to any file.